in this video we're going to talk about factoring to solve quadratic equations. So let's review a couple of definitions. So the first one is roots, which is the x-intercept of quadratic functions, or the solutions to the quadratic functions. You know how to factor a quadratic function, but how do we actually get the solutions? The zero product property, which says that for every real number, a and b, if a times b is equal to 0, then a equals 0 or b equals 0. So for example, when we factor, we get something like x plus 3 times x plus 2. We set it equal to 0. This is how we get our answer. Then x plus 3 equals 0, so in other words this part equals 0, and x plus 2 will equal 0. So either one of those can be set equal to 0. That's what's called the zero product property. Okay, so let's use the zero product property. If we factored and we've gotten x minus 7, x minus 3 equals 0, we're going to break them apart. X minus 3 equals 0. We'd add 3 to both sides. In other words, we just solved the equation. We get x equals 3. X minus 7 equals 0. We add 7 to both sides. We get x equals 7. So our solutions to this equation would be x equals 3 or x equals 7. Okay, what about this one? If we have t times t minus 1 equals 0, we set t equal to 0 because we have this out here. Or we set t plus 1 equal to 0. Subtract 1 from each side, we get t equals negative 1. So our solution here would be t equals 0 or t equals negative 1. What if we have this? In case you can't see, this is 7x plus 12. We factored and got 7x plus 12 or times 5x plus 4. We still set both of these equal to 0. Now this is still solving, but it's a two-step equation. So we would do minus 12 on both sides and then divide both sides by 7. So we're going to get x equals negative 12 sevenths and x equals negative 4 over 5. So our solutions here are x equals negative 12 sevenths or x equals negative 4 fifths. So in other words, after we've factored, we set it equal to 0. We set both of our sets of parentheses equal to 0, and whatever this is going to be our solution. And really what that gives us is our solution. Say we have our negative 12 sevenths and 0. This is an ordered pair. This is where that quadratic, or your parabola I should say, crosses the x-axis. Okay? So now let's go back. Let's go the whole way. Let's find our roots from factoring. First, you want to make sure your equation is in ax squared plus bx plus c. So this one, we have negative x squared plus 16x equals 0. So we don't have a c value. That's okay. All we can factor out of both of these is a negative x, which leaves you with x minus 16. Now we're going to set both of these equal to 0. So we've got this one out here, negative 1x, or just x equals 0. If you just have this value out here, you can just set that equal to 0. Then you take this part and set it equal to 0. X minus 16 equals 0. Solve them both. There's no solving to do for this. Here, you've got to add 16 to both sides. You get x equals 16. So our solutions in this situation are x equals 0 and x equals 16, or possibly we should say, or. Okay, what about here? This is in ax squared plus bx plus c form, so we're going to break them apart and set each equal to 0, and then solve. So for this, we want to add 1 to each side and get b equals 1. Over here, I'm going to subtract 4 from each side and get b equals negative 4, so that my solutions are b equals 1 or b equals negative 4. Let's do a few more. Alright, let's say we have 3q squared plus 16q equals negative 5. This one's not in standard form. Remember, in standard form, it's ax squared plus bx plus c, and it should be able to be set equal to 0. So the first thing I want to do is bring this negative 5 over. Well, when I bring that negative 5 over, this becomes 3q squared plus 16q plus 5 equals 0. Okay, so now I've got to go back, and this has an a value, so I'm thinking if I multiply 3 times 5, I get 15. So I'm looking for factors of 15, sum of 16. So my factors of 15 and sum of 16 are going to be 15 and 1. So I can break this up into 3q squared plus 15q times 1q plus 5. So when I factor everything out, I can factor out a 3q here, and I'm left with q plus 5. Factor out a 1 here, and I'm left with q plus 5. So here I would have 3q plus 1 times q plus 5, and then I continue going. Solve this side, minus 1, divide by 3, I get q equals negative 1/3. That's one solution. On this side, all I have to do is subtract 5 from both sides. So here's my other solution. So here are my two solutions. Okay, what about this one? 4q squared equals 25. Remember, I need to set it equal to 0 before I can solve. So I'm going to subtract my 25 over here first so that I have a problem where I'm subtracting from 0. So then, this one becomes a special case where it's a squared minus b squared, because these are both perfect squares. Hopefully you recognized that right off the bat. So now I have 2q minus 5 and 2q plus 5, and now I'm just going to solve them. Add 5 to both sides and divide by 2. So one of my solutions is 5 halves. The other solution is negative 5 halves. Okay, so what about this one? I know you can see what the answer is, but let's look at why. If I multiply 17 times 3, I get 51. So now I'm looking at what are my factors of 51 that add to give me 6. Well, 51 is a prime number. Well, obviously it's not a prime number because you can do 17 times 3, but there's no way to multiply and get 51 and add and get 6. So we call this whole thing prime, no real solutions, or we'd say it's not factorable, at least not in a way that you know how to do at this time. So we don't have to do anything here except for write no real solution. So that's how you find roots by factoring. You factor it out, set each piece equal to 0, and then find what does your variable equal in your equation.